Welcome to today's lesson. So we're going to be going over Module 6.4 and 6.5, transforming linear functions and comparing properties of linear functions. Let's get started. So your first vocabulary word here is function family. What is a function family? It's just a set of functions whose graphs have basic characteristics in common. So it's functions that look similar. So in your notes, you have your chart that has different types of function families, and we've spoken a little bit about quadratics, which would be these. And quadratics all have that U shape, which if you remember in class I called parabola, but obviously the one that we've been talking about most these last few weeks are linear. And for this lesson, we're just going to be focusing on linear, but I wanted you to have this chart just so you could see the other function families, like cubic and roots and constants and absolute value, which isn't on here, but absolute value would have a V shape. And function families, again, it's just any graphs that have that characteristic. So any graph that looks like a line is going to be part of the linear function family, right? Doesn't matter where the line is, as long as it looks like a line, it's going to be part of the linear function family. Any function that has that U shape, that parabola shape, whether it be a little narrower or wider, it will be part of that quadratic function family. Okay, today we're only going to be focusing on linear functions, and we're going to be focusing on how we could transform linear functions, move them up and down, shrink them, reflect them. That's what we're going to do today. Parent function is the most basic function of a family of functions. We're focusing on linear, and the parent function is already there, but just think of it. What would the most basic linear function look like? The most basic. Well, we know that linear functions have a slope and they have a y-intercept, okay? And it's y equals, if we're writing this as slope-intercept form, it would be y equals mx plus b. What's the most basic slope that we could have? 1, right? So the most basic slope that we could have would just be 1x. That's the most basic slope, 1 over 1. Okay, and what's the most basic y-intercept that we could have? Well, that would just be right at the origin at 0. So what is the most basic function of a linear parent function? It would just be 1x plus 0, or y equals x, right? Or f of x equals x, if we're writing it in function notation. That would be the most basic function of a linear function. And that graph is given to you on the chart that I made. So that graph would just go right through 0, which would be your y-intercept, and it would have a slope of 1, 1, meaning we rise 1, we run 1, we rise 1, we run 1, we rise 1, we run 1, etc., etc., etc. That would be the most basic function of a linear family. Parameter of a linear family, and we just spoke about this, but the parameter of a linear function is what gives a linear function its shape, its direction, its starting point. And if we think of a linear function, the parameters of a linear function, hopefully you know what gives a linear function its steepness, and that would be the slope. So the slope would be one of the parameters, and where we start off on a linear function, if we have it in slope-intercept form, would be your y-intercept. So your y-intercept would kind of give it its position. So those are your two parameters of a linear function: slope and y-intercept. Now let's talk about actual transformations. We're going to first start by talking about translating, okay, and specifically vertical translations. So a vertical translations, all that does is move your line either up or down, okay? So if we look at our parent function, which is y equals x, right? What would we need to do in order to move y equals x up or down? What would we need to do to shift it up or down? Well, really, all we would need to do is change the y-intercept, right? Y-intercept in y equals x is 0, right? So if I change that to y equals x plus 1, what am I doing to my parent function? I am shifting it up 1. So my y-intercept is right here. Is my slope different? No. It would still be 1, 1, 1, 1, 1, 1. Rise 1, run 1. Rise 1, run 1. Okay, so my slope would remain the same, and make sure you write this down in your notes, but I would have shifted it up 1. Okay, so how do we shift up, or how do we shift the line up or down? All we need to do is change the y-intercept, right? If you want to change the y-intercept and you want it to shift down, obviously you would subtract. If you want to shift and go up, you would add. But the slope, though, remains the same, because all we really want to do is shift it up or down. We don't want to change the steepness of the graph. So this right here is my y equals x plus 1 function, which I shifted my parent function up 1. Now what about if I want to shift it down maybe 3 or 4 spaces? So remember, your parent function is x plus 0. So if you wanted to shift it down, we would change the y-intercept to, if we wanted to shift it down 4 spaces, we'd subtract our y-intercept by 4. So 0 minus 4 would be -4. What would that look like? Well, we're shifting it 4 spaces down. So now our y-intercept is going to start at -4, right? B is -4, but our slope is the same. So it's still rise 1, run 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. So all we're really doing here is just shifting the line down 4 spaces, but our slope still is exactly the same. More or less steep. Okay, so this is called a stretch or a shrink. And what that does is it just makes the slope more or less steep. So in this one, the y-intercept is going to stay the same, but the slope is going to change. So for example, if we wanted to make this line steeper, okay, if we wanted to make it steeper, what would we have to do to the slope? And think about slope. Remember, slope is rise over run. Okay, so if we want to make it steeper, if we want to make it climb up faster, we're going to have to change our rise. We're going to change our numerator, which means we're making our slope bigger. So how do we make our graph more steep? We increase our slope. Okay, how do we make our graph less steep? Okay, well, to make it less steep, right? So here we have a slope of 1, right? M is 1 for our parent function. We make it less steep, what would we have to do? We'd have to make 1. We'd have to make our slope less than 1. We'd have to make it into a fraction, right? But be careful, because we don't want it to be a negative. Because if you remember from slope and our lessons on slope, what happens when we have a negative slope? Well, it's actually going to switch the direction of our line. Instead of going up from left to right, we're going to be going down. So to make it less steep, right, we want our slope to be less than 1, right? But we also want it to be greater than 0. We don't want our slope to be a negative number. We just want it to be a fraction, and we can make that fraction as small as we want, and it would make our slope less steep. It would make our line less steep. So let's do a quick example that we could put in our notes. So our parent function has a slope of 1, right? So if we wanted to make this graph steeper, we'd have to increase our slope. Make sure you're writing all this down in your notes. So if our parent function has a slope of 1 and we want to make our line steeper, we have to increase the slope. So I'll just go ahead and make it 2. So what would happen if my slope is 2? Y-intercept is still the same, but now we are rising to running 1. Rising to running 1. Okay? Converse of that is true as well. All right, and then we go ahead and connect this with a line as straight as possible, and you can see that our parent function is much steeper now. Our y-intercept stayed the same, but now the line is much steeper. If we wanted to make it less steep, all we would have to do is change our slope to something that's smaller than our original slope. But we need to make sure that it's not negative, though. So our original slope was 1, right? So if we wanted to make it smaller, we change it to a fraction. That would be 1/2 x. So our y-intercept is still the same, but now I am rising 1, running 2. Rising, run, 1, running 2. The converse of that is true as well. Okay? And if you look at that red line, which would be y equals 1/2 x, that's a lot less steeper than our parent function. So to make the graph stretch or to increase or to make it more steep, what you're going to want to do is increase the slope. If you want to make it less steep, you're going to want to decrease the slope. But remember, do not make sure it's between 1 and 0. Make sure you make it into a fraction. Do not let it become a negative, because that'll just flip the direction of the line, which is actually what we're doing next, reflection. So what is a reflection? A reflection flips a line over the y-axis, and that kind of already gave you a hint in the previous slide of how to do a reflection. With the reflection, all we're going to do is have an opposite slope. We're not going to change the y-intercept. We're just changing its slope to its opposite. So, for example, in the parent function, our slope was y equals x, so our slope was 1x, right? You could put a 1 there if it helps you visualize it. So if we want to reflect it, it would be y equals negative 1x. Okay, and a reflection, all it does is flip the line over the y-axis, right? So if we're reflecting the parent function, then that would make our reflection y equals negative x, right? And if we're graphing that, our y-intercept is still the same. It's still 0, 0. But now, our rise, we are going down 1 and then running 1. Down 1, then running 1. Down 1, and then running 1. Okay? So, if you look at this, a reflection, all it does, my line isn't straight at all, I'm sorry, but a reflection, all it does is flips the line over the y-axis. And all you have to do to find a reflection is just change the slope to its opposite. So here we have 3 lines, right? And we're going to try to identify the parameter that is being changed. So if we look at line A here, the slope, or actually let's start with the y-intercept. The y-intercept would obviously be 0. And what would the slope be? Well, we're rising 2, running 1. So if we wanted to write an equation in slope-intercept form, well, our slope is 2 over 1, right? So it would be y equals, slope is 2 over 1, or 2x. And what's our y-intercept? 0. So it would be plus 0. Now we're trying to figure out what's actually changing, okay? Is it the y-intercept? Is it the slope? Is this going to be a translation? Are we shifting up or down? Or is this going to be a stretch or a shrink? Or is this going to be a reflection? You can kind of already tell it's not going to be a reflection just by looking at it. But if we look at this, let me erase this part. What's happening from point A to, or from line A to line B? It looks like our y-intercept changed, right? Our y-intercept at line A was 0. What's our y-intercept at line B? Negative 1. Is the slope different? No, if you look at the slope, and I'll do this in blue, the slope is still 2, 1, right? 2, 1. The slope is still 2. The only thing that's changed is the y-intercept. So the equation for line B would be y equals, the slope is the same, but we shifted down. Not 2 spaces, I'm sorry. We shifted down 1 space. So our new equation is y equals 2x minus 1. Let's take a look at C. Okay, what's happening at C? Okay, it looks like, again, the slope is the same, 2, 1, but what changed? Our y-intercept. Okay, what happened to our y-intercept? Our y-intercept is now 2. So if A was our original line, what happened from line A to line C? It looks like we shifted up 2. Okay, and how did we do that? Well, we just added 2 to our y-intercept. It was y equals 2x plus 2. So what was the parameter that's being changed? The y-intercept is being changed. And that would be your answer. Now let's take a look at this problem here. So if we say that A is our original line, okay, it looks like the y-intercept for line A is going to be 1. And what's our slope? It looks like it's going to be 2, 2, or 2 over 2 will just be 1, right? Hope you guys realize that. So it would just be y equals our slope, which is 2 over 2, x. And then our y-intercept plus 1. Well, what is 2 over 2? 2 over 2 is just 1x, or just x plus 1. So line A would be y equals x plus 1. What's happening with line B? This is line B right here. It looks like our y-intercept is the same. Our y-intercept is still 1, so it's still going to be y equals something plus 1. But what's happening with the slope? Okay, so for line B, well, our slope is going to be 2, 1. 2, 1. Our rise is 2, and our run is 1. So our slope is actually going to be 2x plus 1. We are making our graph more steep by increasing the slope. Okay, so that is what's happening with line B. We are increasing the slope. What's happening with line C? Okay, well, line C is this one right here. And it looks like, again, our y-intercept is still the same, right? It's still going to be plus 1 if we look at our y-intercept. But now our slope is negative 2, 2. Negative 2, 2. So our slope would be negative 2 over 2x, which is just negative x plus 1. So when we compare that to our original function, our original line, which was y equals x plus 1, what's going on? We have the opposite slope, which is causing a reflection between our original line. All right, a gym charges a one-time new membership fee of $50. So obviously $50 right at the start, so that's going to be your y-intercept, right? Hopefully by now you're getting a little bit better identifying that given a word problem. So we know our y-intercept is going to be 50. And what's our slope? Well, what's our constant change in this word problem? It looks like our constant change is the monthly membership fee. Again, that's constant. It's always going to be $25 a month, right? So that's your slope, 25 over 1. Now, you don't have to actually write the linear equation for this when they give it to you. It's y equals, we know our slope's 25t, and we know our y-intercept is 50, okay? So it says the gym decreases one-time fee for new members. So we're going to go ahead and plot a new line that shows what would happen if the gym were to decrease its one-time fee for new members. Now, it's not saying what the new fee is going to be, but it is saying that, hey, we're decreasing it. So if we look at this coordinate plane here, it looks like the easiest number that we could choose to decrease our membership fee to would be this tick mark right here, which would be 25. So let's go ahead and decrease our membership fee to $25. Well, what are we doing when we decrease our membership fee to $25? We are decreasing the y-intercept. We are subtracting 25 from the y-intercept. So what do you think is going to happen to this line? Hopefully you were able to answer that question. What's going to happen to this line is it's going to shift down by 25. It's going to shift down. Is our slope going to change? No. Our slope is still going to be the same. Our slope is still going to be rise 25, run 1. Rise 25, run 1. Rise 25, run 1. Rise 25, run 1. So our slope is still going to be the same. The only thing that happened was we shifted our line down 1. So here, a gym charges a one-time new membership. Oh, you already know that. But this time, the gym is going to lower its registration fee, but raise its fee. So if our original function was y equals 25t plus 50, what would happen if we lower our registration fee? So let's again lower it to $25, but raise our fee. So instead of $25 a month, let's say our fee was now $50 a month. So what would that do? That would actually change the slope. It would actually be 50t, y equals 50t plus 25. And I challenge you to go ahead and pause it and try to think of what's going to happen to this line, because we're actually doing two transformations here. We've increased the slope, okay, which hopefully you already know what it means, what happens to our line when we increase our slope. And we've also decreased our y-intercept. So pause the video and try to think of what's actually going to happen to this line. Well, our decrease in y-intercept is going to make our line shift down, right? But our increase in slope is going to make our line more steep. It's going to make our line more steep. So we're actually shifting down and making our line more steep all at the same time, right? So our y-intercept is going to be 25, but this time we are going to rise 50, run 1. rise 50, run 1, rise 50, run 1. So do you see how not only did our line shift down, but it also became more steep. It also became more steep. So if we are analyzing this, it looks like, yeah, we're going to save money initially when we first start going to this gym. After 1 month, it would already cost the same amount of money as the previous price that this gym charged. But after 1 month, though, we'd be spending a lot more money than the previous amount this gym charged if they lowered the registration fee but raised its monthly fee. And that's what you would do if you were analyzing the slope, and you would if you were analyzing these two linear functions, which we are going to analyze linear functions tomorrow in class. All right, so that's it. Have a great day. See you tomorrow.